So Chapter 12, Exercise 6, asks you to give the IUPAC name, and these are going to be for aldehydes or ketones. An aldehyde is when you have a carbon double bonded to oxygen with at least one hydrogen also bonded to the carbon. And that's an aldehyde. And a ketone is when you have a carbon double bonded to oxygen with a carbon on both sides. That is a ketone. And the suffix for aldehyde is Al. The suffix for ketone is ONE. All right. So let's try to name a few of these. Here, there aren't any branches, so we'll just go prefix, infix, suffix. Prefix, we have 1, 2, 3 carbons. 3 carbons, the prefix is prop. If you notice, in between here, we have all single bonds between the carbons. I know that there's a double bond between the carbon and the oxygen, but that's part of a functional group, and that will be represented in the suffix. But in terms of there being double or triple bonds between the carbons, nope, there's only single bonds between the carbons, so the infix is AN. We do have a functional group, and the sign for that, the signal for that, if there weren't any other, is that you have the symbol for an element other than hydrogen or carbon in this. And so what we have is a carbon double bonded to oxygen, single bonded to hydrogen, and that is an aldehyde. So this right here, carbon double bonded to oxygen, single bonded to hydrogen, that's an aldehyde, and so the suffix will be Al. Now for aldehydes, you don't actually have to give the number for them for small aldehydes. If an aldehyde is the only functional group on the molecule, which will be the case in principles of chemistry, you don't have to give a number for it. It will always be at position 1. Notice that carbon can only have 4 bonds. To have an aldehyde, you'd have to have 3 of the bonds already taken. 2 of the bonds to oxygen, 1 to hydrogen. So 3 bonds are taken. There's only 1 left, which means this aldehyde will always be at the end of a carbon chain. It'll always be at position 1. So you don't have to say where aldehydes are, because they're always at position 1. And the name for this would be propanal. Now you may have a professor who's more lenient and would let you write 1-propanal, but the official name would be propanal. All right, let's try to name this one. And we do have a branch here, so we need to find the parent chain. The parent chain is going to be the longest carbon chain we can find without going back or lifting up our pencils, but that includes the functional group. And we know we have a functional group because we have an element other than carbon or hydrogen on here. So we know that this carbon right here has to be in the backbone. Actually, let me number this with this. So it has to be in the backbone. So we could either go 1, 2, 3, 4, 5, or you could imagine going 1, 2, 3, 4, 5. Either way is fine. Both of those numberings, those tie, so either way, either one you consider the backbone will give you the same name. I'm going to go with the green. So that will be my backbone. I'm going to circle this, all part of the backbone. There are 5 carbons, and so the prefix is pent. Between the carbons, again, we're talking just between carbons, there's the all single bonds, and so the infix is AN. And it's true, there's the double bond between the carbon and the oxygen, but that's part of a functional group, and so that will be represented in the suffix. So the infix just represents all of the bonding between carbons, and that is all single bonds here. Finally, we have a functional group, and that functional group is a ketone. It is a carbon with a double bond to an oxygen and carbons on each side. So this is a ketone, and the suffix for ketone is ONE, one. So this is a pentanone. Ketones can occur anywhere in the middle of a chain, and so you have to say where precisely it's occurring. The ketone here is occurring on carbon number 3, and so we'll put a 3 in front. Always between numbers and letters goes a dash. The backbone here is 3-pentanone. Now we do have a branch. Now that we've named the backbone, let's move on to that. We have a branch, and it's attaching to the backbone and carbon. The way we've numbered it, it was carbon number 4. But you could imagine numbering it right to left, and if you did number it right to left, you would get 1, 2, 3, 4, 5. Now, if you number it right to left, you still get the same number for the ketone. The ketone is more important than any carbon chain, so if there were ever a conflict, you would want the ketone to have the lower number. But in this case, the ketone gets the same number no matter how you number it. So it's better to number it the blue way, because that gives the other branch the lower number. And the green way of numbering the branch we're talking about now would be on carbon 4. In the blue way, it's on carbon 2, and so we want to number it the blue way. So this branch is going to be 2, always between numbers and letters goes a dash. There's only one carbon in this branch. The prefix for one carbon is meth, and when it's a branch, always after that prefix comes YL. So we can take this 2-methyl and put it in front of the backbone name. Always between numbers and letters goes a dash, and so the name for this whole molecule would be 2-methyl 3-pentanone. Here. Now here we have a ring and we have branches. We know that the ring has to be the backbone because the ring has the functional group on it. So I'm going to circle that ring. Remember that the backbone or the parent chain is the longest carbon chain you can find without going back or lifting up your pencil. That includes the functional group. So here that's the ring. Now that has, you want to number it to give the functional group the lowest number, 1. And I can number this either clockwise or counterclockwise, but if I number it clockwise, I'll get a lower number for the branches. So I'm going to do that. You can see there's a total of 6 carbons here, so the prefix for this will ultimately be hex. Remember, though, that it's going in a ring, so before that prefix, you want to put cyclo. Cyclo, there are 6 carbons, so hex. Between those carbons, all single bonds between the carbons, so AN, and then the functional group is a ketone. You can see that here. It's a carbon double bonded to oxygen, and then that same carbon, it has a carbon on both sides, and the suffix for a ketone is ONE. So this is cyclohexanone. Now, technically, you don't have to include the number 1 in front of this, because since the ketone is the most important thing on the ring, it's taken for granted that it is going to be at carbon 1. You start numbering at the most important thing. But a lenient professor may allow you to put 1 cyclohexanone. Technically, it shouldn't have the 1 there, because it's not necessary information. It's redundant to write it. Okay, now that we've named that backbone, let's name each of the branches. We can see that our first branch is coming off of carbon 3. There's only 1 carbon in that branch, and so the prefix will be meth. Always between numbers and letters goes a dash, and because it's a branch, immediately after that prefix comes YL. We have another branch coming off of carbon 4. Always between numbers and letters goes a dash. There's again only 1 carbon here, so the prefix is also meth. And because it's a branch, immediately after that prefix comes YL. Now these two branches are the same type of branch. They're both methyl branches, so we can smush them together. Take the numbers and separate them by commas, 3, 4. Always between numbers and letters goes a dash. Then you have to say how many branches you've smushed together with a little prefix. We've smushed 2 together, so I'm going to use the prefix di. And finally state the type of branch, so methyl branches. And so that's what those 2 branches are called when you smush them together. Now we just have to put those branch names in front of the backbone name. Oops. And so the name for this whole thing will be 3,4-dimethyl cyclohexanone.